In this video, we're going to see how to find the basis of a solution set for a homogeneous system of equations. So I have a homogeneous system written down here, and the first thing we're going to do is we're going to solve it just like we're working an E3 problem. So to do that, we'll write down the corresponding augmented matrix here. So we have 2, 3, 1, -6, and 0. 1, 1, 1, -1, 0, -1, 4, -6, -19, and 0. And the first thing we'll do is compute the reduced row echelon form, which will give us a simpler system to deal with. So I've gone ahead and typed this into Wolfram Alpha. And we produce 1, 0, 2, 3, 0. 0, 1, -1, -4, 0, and the bottom row is all zeros. So this corresponds to the simpler system x1 plus 2x3 plus 3x4 is 0, and then x2 minus x3 minus 4x4 is equal to 0. Now if we look at our matrix here, go ahead and circle those pivots if we like, and we see that leaves us with two non-pivot columns. So those are our free variables, so we can let, say, x3 be A and x4 be B, and we can rewrite our system in terms of x3 is A and x4 is B, so we'll do that over here. So we have x1 plus 2a plus 3b is equal to 0, and x2 minus a minus 4b is equal to 0. We said x3 was a and x4 was b. Now, as soon as we solve for x1 and x2 in these first two, we'll be able to write down our solution set. So x1 is minus 2a minus 3b. x2 is a plus 4b, x3 was a, and x4 was b. So our solution set is the set of all vectors of the form -2a minus 3b, a plus 4b, a, b, such that a and b are real numbers. Now, the key thing to note here is that this vector, we can split this up as a vector containing a's and a vector containing b's. So the a part looks like this, and the b part looks like -3b, 4b, 0b. And note that that's the same thing as a times -2, 1, 1, 0 plus b times -3, 4, 0, 1. So our solution set here is actually the span of these two vectors, -2, 1, 1, 0 and -3, 4, 0, 1. So we know our solution set is spanned by those two vectors, so now all we need to do is find a linearly independent subset of those two vectors to have a basis. The good news is, because we have these two free variables, we know that these two vectors are always going to end up being linearly independent. In fact, just look at these last two components, the 1, 0, and the 0, 1. So we write down a set containing these two vectors, -2, 1, 1, 0, and -3, 4, 0, 1. This is a basis of the solution set.